Hello and welcome to Beginners Python and Machine Learning 062. We're just a few seconds early, so I'll just wait for 5:30 and then we'll get underway. Okay, so today's the first Tuesday in June, and the first week of every month we try to go back to an absolute beginners session and teaching people who've never seen Python before. So I've tried to structure today's lesson like that. It's going to be a follow-on to Getting Started 1, which we did back in April on Meetup 054. But feel free to ask any questions that you like, because this should still be possible even if you didn't do the watch the video back in April. So let's see, I'll just tidy up here. You can ask questions on YouTube chat, or you can ask questions on the Slack chat. Now, on the YouTube screen in the info down below, you'll see a link to a Google Colab notebook. So if you can click on that link, that'll open up a copy of the workbook that the notebook that we'll be working on tonight. So that will save you a lot of typing, and you can make changes to it, and you can save it in your own area. I think it will require you to have a Google account to be able to do that. But it means you don't need to install Python on your computer to run this, because it'll all be running on the Google servers. If you want to use the workbook, the notebook for last session, I've put a link for it here as well, but best if you watch that video when you're using that notebook. So first of all, I'll recap on how Jupyter notebooks work. They've got a series of cells. So in the cells, like this is a cell up here, this is a cell. In each cell we can have text. This is just written up using markup. Or you can have Python code. And so this cell here is Python code. And you can see up here we can add a cell, which is a code cell, or we can add a text cell with those buttons there. The cells will get added automatically when you're at the end anyway. If you want to add additional cells in, there's some keyboard shortcuts to it. So generally I look in the Tools menu under Keyboard Shortcuts, and you'll see there's a whole bunch of shortcuts here. So the useful ones for me are add a cell below, add a cell above. So Command or Control M, A, Command or Control M and B for cell above, cell below. When you want to run a cell, which is called executing a cell, you do Shift Enter. Okay, so let's try some Python. And remember, let me know in the chat if you have any problems with what I'm doing, or any questions. Yeah. Okay. So just to recap on the last session, we're storing data in variables. So variables can have any name. Here I've called these names my int, my float, my bool. As long as you haven't picked a Python reserved word, it'll save it in that name. Now you'll get an error. You don't need to know what the reserved words, all the reserved words are now. You'll just get an error if you try to use one. You use the equal sign to put data into that variable. So here we're putting a 5 into this variable called my int. Here we're putting a 5 into the variable called my float, and we put a full stop there, like a decimal point, to indicate that it's a floating point or decimal number. So I could have written 5.0 there. I've just written 5 point. That's also good enough. other data type that we looked at last time was the Boolean data type, and that can be true or false. And so that's, if we're checking for things, we check if they're true. The result is true if something is correct and false if it's not. Strings are where you put text. I've got a string here. You can enclose strings in double quotes or single quotes. Inside the string, you can see this string here, I've got a single quote. So it made sense for me to use a double quote on the outside of the string, and that way I can use single quotes easily on the inside of the string. I can create a list of different data types, and we use square brackets to indicate that list. And in there I can put all sorts of different data. So in fact, I've used variables here. I could have put literal values like I've been using up here, but I've put in my int for this variable, so that'll have a 5, a 5.0, a true, and a string with beginners Python and machine learning in it. And a tuple is really a mutable form of a list. It's just a list that you can't make changes to once you've created it. Okay, so I've put quite a lot in this one cell. You could have just put one line, but I've put quite a lot in there. So I'm going to execute it now by pressing Shift Enter or Shift Return. And I've selected it, and we'll go Shift Return now. And you can see it's starting to run the cell, and then the results of what is in that cell will happen below it. Now the very first one we run is a bit slower, but there we go, it's now run. So it's run all this stuff at the top here, and then it's run these few print commands, and the print commands have displayed the results. So you can see I'm printing the words my int, and then I'm displaying the value of what's in that variable my int. And the way I've done that is I've used this special form of string called a format string. And you can use format strings in Python 3.6 or later. And the way you create a format string is to put an F before the quotes that start the string. And then that means that any time you have these curly braces inside the string, you can put an expression in there, and it'll evaluate the expression and print the result of the expression and not the letters that are in the curly braces. So my int is an expression which just says look at the variable my int, and in there is the number 5, and so it's printed the number 5. So you can see it's printed my int space 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 colon space and then my int, which is a 5, and that's the result of this line here. Now format strings are really, really powerful, so I try to use them quite a lot. And I recommend you use them a lot yourself to get used to all the different things that you can do with it. It's the most powerful way of formatting output in Python. There's been some other ways in the past using % signs and strings with a dot format, but for the moment, well, for now, we've got this way of doing it, and so I would recommend just trying to use it as much as possible and learning all the its capabilities. Here's an example of using print without using a format string. So we've got print, and we just put commas between the different things that we want to print out. So the first thing we want to do is print out a my string, which is a variable and whatever's in that, which will be beginners Python and machine learning. The second thing that we want to print out is this expression here, and you can see that's a string calling a format method, passing in the values of these variables, and they get passed into these curly braces. So this is the pre-Python 3.6 way of doing format strings. So you might see that in your travels. You can see this is a little bit harder to use than the format strings that we've used up here. But it does have the advantage that if you've got one variable used twice in your string, you can just refer to it. You just put it one variable here, and then you just refer to it. That's argument 0, argument 0. I've used that twice, and argument 1, I've used that once. Okay, there's your comma. So the next argument into print is that expression there. So it's going to evaluate that and put the result out. And then right at the end, I've said print out all these results, and wherever there's a comma, I want to separate the results with a colon. And so that's printed out this line here, beginners Python and machine learning, colon, true has value 1, colon, 5 plus true divided by 5, colon, is 1.2. Now when you're using Jupyter Notebooks, which is what this is here, there's another way of displaying the contents of a variable, and that's just putting the variable name. So this doesn't work in Python script. If you just put a variable name, nothing will happen. But in Jupyter Notebooks or interactive Python or in the Python console, you can just do the variable name and it will print out, it'll display the results of just the last thing in the cell for Jupyter Notebooks, and there it is. It's displayed that list. Okay, so now we'll do a bit more recap on what we did last time. One of our exercises was converting the numbers 0 to 20 to text using a list. So we created a list. So the list starts and ends with square brackets. And in that list we put in 21 strings. And each string had the name of a number. So the first number is 0, so we put in Z-E-R-O. The next one's 1, 2, 3, 4, 5. Now by doing that, it meant that we can just use an index to refer to that string in the numbers list, and that index will, the value of the index will also be the number that gets its name used. So here we've written a little script that's going to print out the numbers. So basically this is the bit that's doing all the work. Numbers is a list, I is the index. So if I is the number 2, then what numbers I is the letters TWO. So let's run this little script. I'll press Shift Enter and see what we get. So we've got a loop here. I starts with 0, and then this is the start of a loop here while I is less than the length of numbers. So numbers is a length 21. So while I is less than 21, do whatever in the loop. Now in Python, we can define what's in the loop by indentation. So these two lines here are both indented 4 spaces, and 4 is the conventional number that people will use for the number of spaces for the indentation. And so everything that's indented 4 spaces will be included in the loop. So the first thing it does in the loop is it prints out 2 things. It prints out an I and numbers I and separates them with a colon. And then it increments I by 1 and does the loop again. So the first time through the loop I is 0. Next time it's 1, 2, 3, 4, 5. And it keeps looping all the way through, gets to 20. And then when I is 20, we add 1 to it and it becomes 21. And so it says while I, 21, is less than the length of numbers, which is also 21. That's now not true, so the loop stops. And our code will stop here. We can see numbers I, that's showing here on the right of the colon, and that's, we see the digits 1, 8, and it gives us the name 18. 1, 4 gives us the name 14. So it's successfully converting the numbers to text, and we've just written a little script that will do that. If we want to look in our format string, I thought I'd introduce you with a couple of more features to the format string. is you can format the numbers. So if you put a colon here inside inside the curly braces, then everything after the colon is a format on how you want to display it. So the code here, the D means I want to display it as a decimal number. So it's a base 10 number. So that's right, it's 9, 10, 11. That's printing base 10 numbers. I want it to be 4 characters wide. So if we counted there, we'll have 3 spaces and then the number 0. And the greater than sign there says I want it to be right justified. So that means they're all aligned up on the right-hand side. So just learn these little tricks as you go, and you'll be able to do lots of stuff with format strings. Okay. So we'll move on to the next cell. We want to write a Python program now that converts numbers to text from a bigger range than just 0 to 20. So what are the ways we could do that? Well, we could just add extra numbers onto our list. And so here I've used the plus equals, which basically says numbers equals, which adds on to the numbers list. So numbers is a list with 21 items in it. And then I've got another list here with 3 items in it. And so if I print that numbers now, so let's execute that with Shift Enter. I've now got a list that starts at 0, 1, 2, 3 and goes all the way up to 21, 22, 23. So let's see if that works. So we set I to 22 and print out what the name in our numbers list is. So I is 22 and we get 22 in text. So that did work. The problem, it doesn't scale very well. If we want to have 100 numbers, the names of 100 numbers to be able to print out, we've got to put 100 items in this list. And we think we can do better than that because there's a bit of logic behind how numbers are named. All right, so I want to delete those last 3 numbers from the list that I've added. So I can use this slicing technique to say, give me all the numbers, all the items in this numbers list, starting 3 from the end. That's what the minus means, is from the end, not the beginning. And going on, colon means go up to, and because I put nothing after the colon, it'll go all the way to the end. So it'll take the last 3 numbers, and we want to delete them, so we use the Python function delete. So let's have a look at numbers now that I've deleted them. And we can see this list now goes back up to 20, so I've returned numbers to how it was. Okay, so what we'd like to be able to do is create a list with just the names of the tens in there, and then we combine the names of the tens with the names of the units, and we can create all the numbers up into 99. So let's create a list with just those names in it, and let's have a look at what that list looks like. And as you can see, it looks exactly like what we started with. So we want to split the number up. We'll work with a few examples here. Let's try 27. We want to get a 2, and that will give us the 20. And then we've got the 7, and we can get the 7 out of the numbers list. And then we'll display them with a dash between them. And that way we'll have converted the digits 27 to the name 20-7. So we're going to use a for loop here so we can test a few different numbers all in one go. So we've created a list with a few numbers we're going to test in, and we say for I in that list. And what that does is it loops through. Once again, you can see we've got a colon at the end here, which means we're about to start a code block. And in the code block, we've indented everything 4 spaces. So all those 3 lines will get run every time we go through the loop. and we need to split that number up. So the right number is 7. So how do we get 7 from 27? And one way is we can use this modulo arithmetic, which is percent. So if I say 27 modulo 10, that divides 27 by 10 and takes the remainder. So 27 divided by 10 is 2 remainder 7. So we just want the remainder, which is 7. And so we'll store that number into a variable called right. And left will have what's left over. So 27 minus 7 will give us 20. Okay, let's run that. So 27, we can see that we've split that up into 20 plus 7, and so we get the name 20-7. So that did work. That looks pretty good. You can see what we've got here. We're showing the I in the first column here, then we're showing the left number, and then we're showing the right number, and then we're using an index to get into tens and an index to get into numbers to get the names out. So 5, 2, that gets split up into a 50 plus a 2, and we add them together and we get 50-2. 5, that's a 0 plus a 5. We calculate it out and we get 85. We think, oh, that's not really what we wanted. And 12 is 10 plus 2, but that comes up as 92. And 30 is 30 plus 0, and that comes up to 30, 0. So you see we've got some problems in what we're trying to achieve here. So let's see if we can fix that. Let's see why the problem's occurring first. So if we have I is 5, then right is going to be I modulo 10, which is going to be 5. So that's brilliant. We're putting the number 5 into right. Left is going to be I minus right, so left is going to be 0. And so we can see it's split up correctly, 0 plus 5 for the left and right. But the problem is here when we're trying to work out the tens. So tens, we're taking the left number, which in this case is 0, dividing it by 10 using integer division. So that's 0, minus 2. So that gives us minus 2 as the index. And in our list here, minus 2 is a negative number, so it says take it from the end. So we go, there's minus 1, there's minus 2. So it gives us 80, 85 in the display. So we can see that the problem there is that it's going to be, it's going to show these numbers here when it's at the end. So similarly for 12, that gives us 92. Now we could put 0 and 10 in here for the tens at the beginning, and that would, and maybe get rid of this minus 2 out of this formula, but that would not work. We still get 52 and 27 would be right, but then we'd get 0, 5, and for 2 we'd get 10, 2 rather than 12. So our first task, and this is one you can have a go at, is fix the code up here so that all the numbers display correctly. So we're going to need to check for numbers less than 20. So that's to fix this one, it's 85 and 92, which should be just 5 and 12. And we also need to check for numbers evenly divisible by 10, and that will fix the 30, 0. So when you're doing checks, you would use if statements. So you have if and then a condition. So we'll call this condition 1. And then what the commands you want to do if condition 1 is true. And then we say else if, and that's written ELIF, condition 2. So that's what you do if condition 1 is false and condition 2 is true. And then you can do an else right at the end, and that's if none of these conditions were true, it'll fall through and do this condition. So you're being very quiet on the chat there. Just let me know if you've got any questions, if anything's not clear, if I'm going too fast or too slowly. All right, So I'm going to work through this here, so you can see the process that I go through to write this problem, to solve this problem, and then we'll have a look at the solution that's already provided in the notebook. So I'll copy the code, but I want to do an if statement. So I've calculated right and left, and now I want to first check for numbers evenly divisible by 10. All right. So if it's evenly divisible by 10, I could say if the right number is equal to 0, then it must be evenly divisible by 10. Okay, and see, Jupyter Notebooks has automatically indented another 4 spaces for me, and that's, I put a colon here, so I'm about to start a new code block. So these 4, anything in this code block has to be indented 4 spaces, and then anything after that will go into the else, and I'll indent this one. All right, so if it's evenly divisible by 10, I don't need to do the dash and the numbers to the right. So that's fixed this last one, the 30. That's now displaying correctly. We've still got a problem with 85 and 92. So let's have a look at this. Need to check for numbers less than 20. So I'll do an if statement. If I is less than 20, then we don't need to put the tens in here at all. We can just do numbers and to the right. Okay, so if I is less than 20, then do this. Else, I want to do that. So I've got to change this if to an elif. If the right number equals 0, then display that. Else, just for the normal numbers, we'll do this one. Okay, 27, 52, 5, 2, and 30. All right, so I didn't get that one right. That should be showing 12. And the reason is because I just did numbers right, and I should have done numbers I, because it's I that's less than 20, not right. Well, there we go, 27, 52, 5, 12, 30. And I might just put a 0 in there, see if that shows correctly as well. Yep, 0 comes up properly as well. Okay, let's have a look at the solution. Solution was pretty similar. The only difference here, we put length of numbers, and that's probably a better way of doing it. In case the length of numbers changes for whatever reason, but if numbers does get extended for whatever reason, then it'll automatically just use this quick way of displaying the number in text, because without having to do any calculations. So using length of numbers is probably a good way of doing it. Everything else looks the same. All right, so this is all pretty good, except that this expression left integer division 10 minus 2 is a bit complicated. So if someone's looking at this code later and they look at that and they'll wonder why you've done left / 10 minus 2, it would be really good if we could say tens and 20, and that would give us the word TWENTY. So how can we do this? We use a sparse list, but that's very inefficient from a memory perspective. So I could just have lots of nuns in the list, and then when I get up to index 20, then I can put in the word 20, and then a whole bunch of nuns, and then the word THIRTY. But rather than use that way, which was the sparse list, let's use what Python's got is a dictionary data type, and this is a really powerful data type. You can really write some efficient code using this data type. And what it is a dictionary is a lookup book. You look up a word in the dictionary and you find out what its meaning is. So in this case, the dictionary, you can set what the lookup is going to be, and then you put in what the result that you're going to get back from the dictionary. Now this is also called a mapping. You're mapping the word 20 to the digits 20. So now that means if I create this dictionary, and you can see I've created it with curly braces rather than square brackets. We've put the keys in here, and after each key we put a colon and then the value, and then commas separate these key value pairs. So that's called a key value pair. That's another key value pair. That's another key value pair. And then to look up one of the values, we put a key in the square brackets, so tens of 40, and let's have a look at what that gives us. It gives us the word 40. So that's really good. That's exactly what we need to solve our problem, and let us use tens and then just the number rather than just the word left, the variable left, rather than left / 10 minus 2. So tonight, one of the main things we're looking at is dictionaries. So let's look at a few other examples of what we can do with dictionaries. Our first example, our keys were integers. Now let's try keys being strings. And because they're strings, we have to put in apostrophe quotes around them. So now we can look up D of A, that'll give us alpha. D of B will give us Bravo. D of C will give us Charlie. So this shows that the keys can be a string, and that's what it displays. That you'll see in this string here. I like to just throw in extra things for you to learn along. We wanted to put a new line in our printout, but just use the one print command. So I put a \n, and that means new line. So keys can be string, new line, and then it's showing us the dictionary here. Let's have a look at our next example. I'll run Shift-Enter on this one. Keys can also be tuples. So here we go. I've got a tuple here, 1, 4, 1, 8, 5, 8. They're all our keys. And we've put some strings in there as our values. And so that works as well. In fact, you can use any immutable hashable type for a key. But that means you can't do this, for example, which I had commented out because it doesn't work. But if we try using a list as a key, it won't work because lists are mutable, and we get this error, type error, unhashable type list, and so it can't hash a mutable type. So that's why we're getting the error. So I commented that out just so if someone tries to run all of these cells in one hit by going runtime run all, it'll stop whenever it hits an error. And so that's why I had that one commented out. So what can we do with the dictionary? We've created a dictionary. For example, we've got D is A, Alpha, B, Bravo, C, Charlie. And now we want to add in some more values for some new keys. So we can do that using this notation here. We say D of square brackets and then the key equals delta. And D of square brackets and then the letter E and as a string equals epsilon. So that will change D. So let's run that and see what we get. So we get A is alpha, B is Bravo, C is Charlie, D is delta, E is epsilon. And now if we run it again, if we run those two commands again, not going to do anything new, but they won't hurt what we've already got. And let's run the update, and that can merge a dictionary into another dictionary into our first dictionary. So d.update is going to be updated with this new dictionary. We're going to put in E, we're going to change it we're going to put in echo, and F we're going to put in foxtrot. So if I run that, And you see by setting E in the update, it's overwritten our previous value of E, which was epsilon, because the keys have to be unique. It doesn't make sense to have a key that's not unique because we're using the key to look it up, and if they had two different values, it wouldn't know which value to return to us. So it's replaced E epsilon with E echo, and that's our new dictionary. The dictionary comes with a few functions that help us. We can look up all the keys in the dictionary. We can look up just the values in the dictionary, or we can look up the items, and each item is a key value pair. So let's run that and have a look at what we get out of it. So the keys of the dictionary are A, B, C, D, E, F. That's good. The values are Alpha, Bravo, Charlie, Delta, Echo, Foxtrot. And if we want the items, then they're here like tuples. So they're A Alpha, B Bravo, C Charlie, D Delta, E Echo, F Foxtrot. So these functions are really useful if we want to loop through the dictionary. So we want to create a loop and do everything. So say we wanted to use the keys function. We want to loop through the dictionary. Every time we we get a key, we store it in the variable k. Then we look up what the value in the dictionary is for that key and put it in a variable v, and then we can print k and v. So I'll just type in .keys here. And so that's looping using the keys function in the dictionary, and we get A, Alpha, B, Bravo, C, Charlie, etc. Now, if we do a loop like this and we left the .keys off, it's actually the same as doing dict.keys. So indict is the same as indict.keys. So it doesn't worry about the values, it's just looking at the keys, and so this will work just as well and save you a bit of typing. So that's looping using dict.keys. However, it's pretty common that this is what you'd want to do. You'd want to know the key and the value every time you go through that loop. So we can do that for k comma v in d.items. So each d.item is going to return one of these tuple-like values, and it's going to put the first value in the key, the second value in the value v, and then we've reduced our code by one line, and it does the same thing. So that's how you use dict.items. Okay, task number 2, redo task 1 using a dict for tens. So have a go at that. If you've got any questions up until now, I can answer any questions while people are working on that. If I don't get any questions, I will start to go through the solution. So, and just a reminder, if you're liking this video, just click on like at the bottom, and if you want to see more ones of these, click on subscribe. The subscribe will get you all the ones that I do, which I do half of the ones at Beginners Python and Machine Learning, and then you have to subscribe to Arun's channel if you want to see the more machine learning sessions for Beginners Python and Machine Learning. Okay, let's have a look at task 1. We'll get the solution for task 1, so I'll go back and copy that. Solution 1. I'll paste it here in the cell. Right, so tens is now got our values in a dictionary. So now, rather than left //10 minus 2, I can just do left. And we get the same answer, so that's good. So the code's a bit easier to read now, and so you're less likely to have mistakes in it. And we'll have a look at the solution. Yep, solution's exactly the same as what I wrote. Okay, expand solution to task 2 to handle numbers up to 999. Test on 100, 112, 300, 999. Okay, let's have a go at that. So I'll copy this solution we've got here into the blank cell. And we'll think about what we're trying to do. So if we're doing 999, then we need to look for how many hundreds there are and put that number followed by the word 100 and then the word and then 99. So we're going to test this on some extra numbers, so I'll add them to the end of the list. So the first thing we'll do is we'll see if the number's above 100. If I is greater than 100, we'll do greater than or equal. Hundreds equals the number of hundreds is going to be 100. And now we're going to print, no, we're not going to print, so we'll store we'll get the numbers from there. So we're going to put in front of here, we're going to put in 100. So what we've got down here is good for calculating the remainder, the name for the remainder of the number. Equals I minus hundreds divided by times 100. And so this can be, and there's lots of different ways of doing this. I think I'm doing it differently to the solution. So okay, and in front of that we want to put the number of hundreds. So that can be let's just store it in a string. Hundreds name equals numbers hundreds plus 100, and there we go. Okay, let's run that, see how we go. Remainder equals I minus hundreds. Yep. So I could say hundreds equals 0 up here. Hundreds name is not defined. Yes, of course. So I could put an else in here. Let's do the hundreds 0 and hundreds name equals nothing. Just running that, taking longer than I would have expected. Okay, so 112, that looks good. 112, 300 became 300, that's not good. 999 became 999, that's looking pretty good. And 100 became 100, so that's no good. So what do we have to do here? We have to work out that if there's a remainder here, if the remainder is 0, we don't want to say and 0, we just want to leave that blank. So let's check for the remainder. So if remainder equals 0, now we'll split this up. We've got the hundreds name and we've got the and. So let's put the and in our conjunction, and otherwise we'll put it in so the and will go in a conjunction, so then we can put some logic whether we want to show and or not, and the hundreds name, that'll be blank. So let's press the wrong key there, or conjunction, which just means and. So if the remainder equals 0, junction equals nothing, or hundreds name equals empty string. Otherwise, so that's the remainder is greater than 0 and hundreds name is not the empty string, then conjunction equals and I'll put a space in front of that. No, I'll put a space after it. So I will have a space after 100 here. If remainder equals 0, hundreds name equals empty string, conjunction's that, otherwise it's that. Right equals remainder 10, that looks good. Put this in every case. Right, so we've got the and working, we just need to not show the 0. So for remainder, we need to put a if remainder equals 0 here. And hundreds name does not equal the empty string, then we put that in, and we just want that. That's right, and then this has to be an else if. So I'm trying to show you how to write the code. I could just show you the solution, but trying to show you the way I'm thinking as I'm going through this, and this is how you learn how to program. So we've got 100 is 100, 112, 112, 300, 300, 999, 999. So we've got it all coming out correctly. It's probably not an optimal solution. Let's have a look at the optimal solution, at another solution, and see what the differences were. So we've gone, I'll get rid of that bracket there. I'll just delete this so we can see them both on the screen at the same time. So in this solution, I've gone straight to calculating the hundreds number, and then I'm working on that. If it's greater than 0, I've got the name, and I stick in a conjunction. Otherwise, I've got set the hundreds name and conjunction here. The remainder I calculate. If remainder equals 0 and hundreds name does not equal the empty string, then I do it without, I just do the hundreds name and nothing after it. Otherwise, I do these ones with a conjunction and the old code. I've also put in here some extra code so that we can see how it's broken down, the hundreds number, the tens and the units. So let's run the solution and see what output we get from that. So yeah, 27,000 plus 20 plus 7 is 27. So we're getting the same answers here. It's nice to have a look at some of these, how I've done the breakdowns. So here I wanted to show 0, 0, just to be consistent. And the way I've done that in my format string, I've put a 0 here before the, and that just says what I want to pad it with. So previously, if I don't say anything, it pads it with spaces, and then write justified 2-digit number, decimal number. Okay, Suya has asked, lists are mutable. That's correct. Lists are mutable, and tuples are immutable. So by some of the things where we were changing the list before, if we did, let's go back to our list. This is changing a list in place. And d.update is also changing a list. There's also d.append, so I can append to an existing list. And I think even the plus equals changes the list in place. All right, so now we've got some code which works for numbers from 0 to 999, but we don't have to copy these 18 lines of code every time we want to use them. So we can put the code into a function and then call the function when needed. And that helps with another principle of programming, which is, they call it dry, don't repeat yourself, DRY. So don't copy and paste code. If you're copying and pasting code into lots of different places, then it makes it really hard if you then realize that you want to make a change to that code, and you've got to find all the places you copied it to fix it up. So if you put it into a function, then you just call the function when you want it. Then if you need to update it at any time, so at the moment it works for numbers up to 999. If we work out how to make it up to bigger numbers, then we can just change the function, and then everywhere that it's used, we'll get that extra functionality. So let's have a look at some functions. There's different ways of doing functions. We've got, there are some built-in functions. So anything which has got these parentheses here, that's when you're calling a function. Well, it's not everything, so there's also creating classes, use those parentheses as well. But for most of the part, calling a function, we call it by putting parentheses after the function name. So here's a function called help. If I call that, it pulls up Python's help facility, and now I can type a thing in here that I want to get the help on. So say, for example, I want to get help on copyright. And it gives me help on the printer, is help on printer in module site built-in. So copyright is using the printer, and there's some of the functions on copyright. So let's find a more interesting one. Let's find, I can do help on string.upper, and that returns a copy of the string converted to uppercase. Okay, I'll quit out of the help, type in quit. And I'll just delete that for now. And we'll go back to where I was. Here we go, print. Print is another function. So if I run that, it just prints a blank line. There's also license and copyright. All functions return a value. We see we're not using any return values from these, but they are actually returning a value. So for example, copyright. So if I wrote copyright here, it prints out these values. I'll just put that back to print for now. So it doesn't need a return value, but it does have a return value. So if I say return value equals copyright, or just any variable name here, it'll store the return value from copyright into that variable. So let's run that and see what the return value is. The return value from copyright is none. So it just returned a none, but it did get a return. So that statement makes sense even though it doesn't really return a value. Functions can take arguments. Arguments can also be called parameters, so you'll hear me using both words to describe the same thing. And the arguments go between the parentheses. They can be identified by their position in the parentheses. So, for example, you've seen using the print function used with arguments. So here's an example of print with 3 arguments, and the arguments are separated by commas. And that just prints each of the arguments and puts a space in between them. All right. Here is an example of a print statement with 1 argument, because you can see there's no commas in there. But what I've done is I've created a format string, evaluated the format string, and then the 1 argument is the string that is the result of the format string being evaluated. You can also have named arguments. So these arguments are just identified by their position, and print knows to print that one first and that one second and then that one third. But you can also put in some named arguments, and the named arguments can are for things that you want to maybe specify out of order. So all the named arguments have to go after the positioned arguments. And for example, we can use print. We can say what separator we want to use between the things that are getting printed, and we can say what we want to put at the end of the line. So for example, in this case, we want to put a space at the end of the line rather than a new line. So let's see what happens when we print this. When we run this, the first 2 lines are an example of print with no named arguments, and then the 3rd line and the 4th line are from these 2 print statements, but it's actually this 3rd line is from the 2 print statements. Example of print, so it's used a separator of a dash between those 3 words, and then it hasn't done a new line, it's continued on the same line for this next print statement with named arguments. This time we're using a separator of an underscore, and you'll see that the underscore, I've put the separator this time after the end, so it doesn't matter with named arguments which order you put them in. And then on the end, I want to put a new line followed by 4 less than signs. And so it does a new line and then 4 less than signs. To make it even clearer, let's put the new line in the middle of the less than signs. And you probably should put a new line at the end of the less than signs, otherwise it'll the next thing that prints will just print on the same line. So there we go. It's ended with 2 less than signs, a new line, and then 2 less than signs. All right, let's look at some other examples of functions, built-in functions that have positional arguments. You can use min, which will find the minimum value of a group of numbers that you've supply. We've got sum that will add up all the numbers that you supply. Max will find the maximum value. And for these ones like min and max, you can supply them in different ways. You can just have lots of arguments, as many as you like. Or you can put all the arguments into a list and provide the one list, and it'll find the maximum value out of those lists. So it'll work on either way of doing that. So let's have a look at what we get for there. The minimum value is 2.5. That's what we'd expect. The sum of these is 83.4, so it's added up those values. That's correct. The maximum value, A, C, and G, is C. Possibly not what we're expecting. And the reason for that is it's looking at, to work out which is the maximum value, it's looking at the Unicode value of these letters, and uppercase letters have a lower Unicode value than lowercase. So in this case, C has a higher Unicode value than capital G. And you can see max worked whether I supplied an iterable list or separate arguments. So that's providing one argument and just putting a list in that one argument, or providing 3 separate arguments. Now if I tried sum with 3 separate arguments, it wouldn't work. Let's have a look. So I'm going to do Command M below. I'll click in this cell, Command M below, create a new cell, and we'll say sum of, and I'll just use the same 3 numbers. So 4, 76, 3.4. And I get an error, and it says sum expected at most 2 arguments, but we got 3. Now that worked for min, but why didn't it work for sum? So let's have a look at, we want the help on sum to find out what we're supposed to be giving it. Help on the built-in function sum in module built-ins. It returns the sum of a start value. So it's got a named argument there, start, plus an iterable of the numbers. So it's got a list or a tuple, something like that, with all the numbers that you want to add in. So it'll add up all of those numbers in iterable and then add in the start and then return the result. So if I did 4,76, int object is not iterable, so I'd have to put the 4 in a list. It'll give me 80, and that's because it'll add the to use 76 as the start value and then just start adding all the numbers in the list. Okay, so we've been looking at built-in functions. We're just running them standalone. There's also a group of functions called methods, and they have functions attached to classes. So you can call them by referencing them with the object name of that class, followed by the method name. So we've seen a few of these already. I showed you upper before, so mystring.upper will take the string mystring and convert it all to uppercase. Anyway, we'll just have a look at these. We'll run them. So mystring.upper converts it all to uppercase. Mystring.lower converts it all to lowercase. Now I've used a variable name here and then the function name. Now you could also use a literal string, so Bob's Diner, and convert that to title case, and the result that we get is Bob's Diner. And I don't know why I've got these parentheses at the end. Yeah, Bob's Diner. And I've also got the split function, which takes a string and splits it on, in this case, white space. And so we get Bob's and Diner. And you see how it's representing these. It's seen that Bob's has got a single quote in there, so it's showing it as a string by putting double quotes around the outside. Diner doesn't include a single quote, so it's just using single quotes. But they're both strings equivalently. The title case here, that's worked really weirdly. It says Bob is one word, S is another word, Diner is another word, so it's put a capital on each of those 3 words, so we get a capital B on Bob, capital S, and a capital D for Diner. So we'll look at that again later. So these are the built-in functions or functions that other people have written on their classes. That's how we call them. We can also define our own functions, and that's really where the power of programming is coming. I'm getting someone saying the video is not clear. So if other people are saying the video is not clear, please let me know. Otherwise, I'll just assume it's at the that person's end and not mine end. Okay, so the way we define a function is use def and the function name. So I'm going to call a function show now, and what this function is going to do is print the time is now. So by defining the function, everything that I want to put in the function is indented, and now the function's defined. I can run the function by using the name of the function, show now, followed by parentheses. And that's calling the function. And so when I run it, it says the time is now, and it gives the time, and this is obviously UTC time, so that's whatever time is on the Google server that we're using. So remember before when I did help on sum, I didn't put the parentheses there because I was wanting to refer to the function. I didn't want to call the function. But help, I was calling the function help, so there I did put parentheses on help. And similarly now, I'm calling the function show now, so I put the parentheses on the end of the name and execute it. Okay, Peter's saying his video is fine. That's good. So let's define a function with an argument, and it's going to return a float. So this one's going to convert a temperature in degrees Celsius and convert it to Fahrenheit. So if I define that function, see it doesn't have any output when I define it, nothing actually happens, but then I can run it, I can call it by calling define degrees Fahrenheit and put in this value C, which is our value in degrees Celsius, and I'm going to try 3 degrees Celsius, I'm going to try 0, 100 and minus 40 and see what the Fahrenheit equivalent is of those. So 0 Celsius is 32 Fahrenheit, 100 Celsius is 212 Fahrenheit, and minus 40 Celsius is minus 40 Fahrenheit. Okay, so for the beginners class, that's really what you need to know about defining functions. For people who are more advanced, it's a good idea to provide some more documentation on your function. So here's defining the same function, providing more information about it. So when I want the input to be degrees Celsius, I'm giving a type hint here to say I really expect a float. So a floating point number to be provided for degrees Celsius. It doesn't say it has to be a float, it's just saying that's what I would expect. And the reason you put in this type hinting is so that when you're writing your Python program in an integrated development environment like PyCharm or Visual Studio Code, it can see if you're providing a value to a function that is not what it's expecting, and it can raise a warning for you, and that can be very useful when you're writing code that you're not giving it the right stuff. You also use this dash greater than sign and then a data type to say what sort of data that function returns. And that's also useful in the documentation. And the very first line of the function, we use a string, and we can use a string identified with triple double quotes to say what the function does. And the advantage of strings that have triple double quotes is that you can put new lines in them, so you could have several lines of documentation there if you wanted. And what you would normally do if you were doing that is you would leave a spare line, and then so the first line is a summary of what it does, and then you can write paragraphs, many paragraphs of description describing what this function does and how to use it. Okay, so if I define the function this way, and then later on I forget what I did for that function, I can just call help on degrees Fahrenheit, and it tells me that this function here takes a float, will return a float, gives me a summary, returns the temperature in degrees Fahrenheit given a temperature in degrees Celsius, and then I've got lots of stuff I can read, many paragraphs description describing what this function does and how to use it. All right, Peter's asked, for the show now function, any reason why you wouldn't do the import date time inside the function? Okay, so normally when you're writing a Python module, you would put all your import statements right at the top of the Python module, and all your functions are down lower in your Python module. So it's if you wanted to, you could have just one function in your Python module, in which case it's clear that the import date time is for that function needs to import date time so that it can use it. You can put the import date time inside the function, but that means that every time you call that function, it calls import date time, which is unnecessary because it only has to be called once. The Python interpreter will see that it's been called before and won't actually run it again, but it will slow the function down a little bit to go through that step. Just getting a bit of a dry throat here. Okay, so yeah, to answer the question, I've never seen people actually import libraries inside functions, and that would be what I think the reason is. So we've done help on our function that we've defined. You can also call up the doc string on a function by doing dot. This is a underscore underscore doc underscore underscore. And that just gives us the doc string. So the reason you would call that is if you wanted to do something with it, maybe print it or store it in a file or something for someone else to read. That's how you can get it and store it in a variable. So even though our degree Fahrenheit function was expecting a float, it will still work with other data types. Python's still dynamically typed, so it can handle different data types. So here, for example, we use the complex numbers data type, where it's got a real part and an imaginary part, and see if it can convert that into Fahrenheit. And sure enough, 24 plus 5j degrees Celsius is equal to 75.2 plus 9j degrees Fahrenheit, which of course doesn't mean anything. J there is the square root of -1, which is an imaginary number. Okay, task 4, convert the code from task 3 into a function and return a string. Okay, so currently we were printing a result, but now we're going to return a string. So let's go find the code for task 3. I'll copy all of that. All right, so we don't want this loop. That'll be for when we're calling the function later. So I'll get rid of that. And maybe down the bottom, we'll use that. Okay, so we'll define our function. We're going to call it the name, we'll call it number name. That's the name of our function. And it will take in an integer I, and then we, as our parameter, and then we put a colon there to say this is the start of a new code block, and we indent everything that's going to go into the function. So here's our function. At the moment it prints numbers out, which is, let's just see if it works. So I could just go number name I and run that, and that's calling the function called number name, and each time we call it, it prints something out. But we actually want it to return a string to us with the number name in it, so that we can then do with it what we like. We might want to print it, but there's plenty of other things that we might want to do with it. So rather than having these print statements here, we need to have return statements. Now with a function, I showed you we could return a value. You can actually have several return statements in a function, and whichever one it gets to first will be the last statement that it runs, and then it will leave the function, and nothing else after that will run. So we'll copy one of these print statements out of there because we might use them ourselves. We can print I. We can't do the breakdown because all those variables are inside the function, so we don't have access to them anymore. And then we can just print the name. So we're going to call the function number name of I. And that's going to be a string that we're going to get and we can do something with. So here I can just say return, and it's really whatever that last thing is what we need. Well, for that one it is. For this one, we don't need this stuff at the beginning, but we do need to construct this string. So I'll continue to use format strings for that. Okay, so now our print statements are here outside the function, and we're just calling number name for each of these numbers, and it's returning these strings. So that's what we needed. So let's have a look at the solution. Okay, so I use format strings to add those string values together. In the solution, it's used string concatenation using the plus sign. So either of those is fine. Whatever's easiest for you to understand. Now he's put in, I wrote this, so I put in the type hinting here, :int. We're taking in an int and we're returning a string. I didn't put any doc strings in there. I probably should have done that. And I've changed the argument name from I to number, just to make it a bit clearer. Okay, task 5, expand solution 4 to handle thousands up to 20999. All right, so let's copy this and have a look at what we need to do for thousands. So, well, the first things I would do is find out how many thousands I'm going to need. And then, if that's greater than 0, then I want to store it in a string. Now, I've got a string here called hundreds name and a conjunction, but what I should do is probably just have a string that I'm accumulating these rather. I don't need separate names for each part of it all. So let's have a string we'll just call S, and start with an empty string, and then if thousands is greater than 0, then I can just add on to that the number of thousands. So I need the name for that, and I can use numbers to do this. Numbers of thousands plus 1,000 Okay. And that should do for that. Then I can look at hundreds equals number divided by 100. Hundreds is greater than 0. Then I'll just add on to the string. S plus equals numbers of hundreds. Oh, and I need to subtract. So let's go number minus equals thousands times 1,000. And I've got this line here, number. So each time I get a number, I can subtract it down and then just find the name for the rest of the number. And now for the conjunction, rather than looking for whether it's hundreds or thousands, I can just see if there's any string there already. If S does not equal the empty string, then conjunction equals AND. Don't need anything there. Conjunction equals nothing. Okay. Equals number divided by 10. So here we just need the string S. And we'll put a couple of thousands in here. So we want 2,343, 5, 1,000, 20,999, 21,000. There we go. All right, so let's see how it worked. 27 worked, 52 worked, 5, 12, 30, so all our old stuff worked. 100 works, 112 works, 300. 2,345 worked, 1,000 worked, 20,999. We're missing a space in here after 1,000. So let's put in a space at the end of here, and maybe not one at the end of AND, before the AND. Okay. But when we got to 21,000, it didn't work. So we got this big error at 21,000, and the reason for that is because we were calling numbers with an index of 21 in there, and numbers only goes up to 20. So I'll just wanted to show you that. We'll take it out for now, and that's it working fine with the space. So let's have a look at our solution. That looks the same. Yep, I think that's all pretty much the same. So that's good. All right, and now we'll look at an advanced topic here. Expand solution 5 to handle numbers up to billions. All right, well, let's start. We'll expand the range up to 999,999. So let's take this solution and think about how you would do that. So at the moment we go up to 20,999. We had a problem when we got to 21,000. So what was the cause of that problem is when we started to call this value here, numbers, thousands. But so what we really want to do, like if that's 999,999, we've already got a function that can convert the number of thousands, which in this case will be 999, to the words 999, and we just need to add that in front of the word thousand. But the function that we're we've got for doing that is actually the function that we're in. Now this is called calling a function recursively. We're calling our own function to from within, and every time you call it, it puts a call on the stack, and so that when it returns from this function, it's actually returning to another calling of the same function, and it builds it up from there. So if you're a beginner, don't worry about this. This is calling recursive functions is not something you're going to be doing in the early days of programming. But for people who like a bit of a challenge, who try to understand what's going on, if I call number name from here with thousands, and in fact I like my code to be consistent, so I can call it from here as well, but it doesn't actually make any difference for that one. But from number name thousands, now if I call 21,000 or even 999,000, $21,000 now works, 999,999 also works. So this code here, we've with very little change, we've just this recursive call to number name, we've actually expanded the range from 20,999 all the way up to 999,999. So have a think about what's going on there, and if you've got any questions, just add them onto the chat. Now I'll move on to the next bit, which is how to handle numbers up to billions. Well, let's start with going up to, well, we've got up to almost 1 million now. So the next thing I could do is I could work out how many millions there are going to be, all the way up to 1 billion. If millions is greater than 0, what am I writing here? Millions is greater than 0. Number name millions plus million. Number minus equals millions times 1 million. And so let's try that with 123. And of course I don't put commas in here. So 123,999,999. So this is quite, we've just gone up to 1 billion pretty easily. We could keep adding in billions and quadrillions in here, and our code gets longer every time. Every time we do it, we just get another 3 powers of 10 in there. But there is definitely a pattern that's emerging. So maybe we can write it in such a way that we can take care of the pattern. And this is where we can use a dictionary. So every time we do these steps here, we need to know what the name of the power of 10 is, in this case million, and what the value of it is. So let's store these values in a dictionary. We'll call it powers. So let's say we want 1 billion, and we'll give it the name billion. And we've got 1 million, and that's going to be called 1 million. And then we've got 1,000. And we've got 100. So what we're doing, we're just looping through these, starting from the biggest one and going down. And dictionaries, since Python 3.6, I think it is, are now ordered. So if I create a dictionary like this, I know that those keys are going to be in that order. For earlier versions of Python, you have to use a different class called an ordered dictionary. But we don't have to do that now. So let's see, I could say for power, comma, power name in powers.items, and then I just write this code. So I say power number, power count will do, equals the number that we've got, integer division by the power. And I'm just translating this code here with our variable names. So power count, so that was millions, it could be billions, equals number, which is whatever's been provided in, divided by the power, which in this case is this count, say a billion. So if the power count is greater than 0, then we have to add it into the name. So s plus equals, we want the name of that power count, number name, so we call ourselves recursively power count, followed by a space, followed by the power name, followed by a space. And then we want to reduce number by that many, so that it's we no longer need to find the name for it, because we've already got the name for that part of it. Okay, so I can get rid of all of that code, and it's just all handled in these few lines here. So it still works for all of those numbers. And see, the code's actually got shorter now, but we can go up to even bigger numbers. There we go, 123,456,789,123,534. That's great. It's not actually correct. So it was correct, millions correct, billions is correct, but then up here there should have been quadrillion. But it's now really easy to keep, or trillion. We can really easily expand this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 trillion. And I could even go up to quadrillion. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There we go, 123,456,789,123,534. So we've used the power of a dictionary here to really expand the capabilities of this function. We've used recursive calling of the function to reduce the amount of code that's required to write this function. So think about how you would write this some other way if you didn't have those facilities, and that's when you realize how powerful it is to have dictionaries and recursive calling of functions. Let's have a look in the solution. So I've just got different names here: power, comma, name, and powers.items. Oh, count, I just called it count. I used to format strings here, and I was using string concatenation down here. Yeah, but it's all pretty much the same. So, yeah, let me know if you've got any questions about that. Okay, we'll move on. Task 7, define a better function than string title, for example, Bob's Diner. Okay, so you remember before we had a string and we called the title function on it. And it gave us a capital S, and we really want to have a lowercase s on that. So let's create a function. We're going to call it title. And we're going to take in a sentence that's going to be capitalized. And we've got to think about how we're going to do this. So this is a lot easier than the previous example. So the beginners can jump back in and have a go at this one. All we need to do, the first thing we need to do is split up the sentence into words. So these are comments here, so anything starting with a hash is a comment. Split up sentence into words. Then I want to convert the first letter of each word to uppercase. Word to uppercase. And every other letter to lowercase. And we'll store that into a new dictionary, a new list we will do. And then join the new words back into a sentence and return them. Return that value. Okay, so to split up a sentence into words, we use the split command, and that'll give us a list of all the values. So let's say list original equals sentence dot split. Okay, then we're going to create a list of the words with proper title case. So I create an empty list, and then I'll loop through each of the words in list original. So W is the word in list original. And then I'm going to word with title case is going to be the first letter of W in uppercase. So remember, we can refer to each letter in a string by using square brackets and an index. So that'll give us the first letter. And then we can get the rest of the letters by using slicing, which is, once again, we use the square brackets for an index. We say where we want to start from, we do a colon, and then we want to go to, but we want to go right to the end, so I just leave everything after the colon blank, and I want that to all be lowercase. Okay, then I want to append that new word into my list title. Because it's immutable, list's immutable, I can add things to it. Word with title case. Alright, so that'll give me my list of words in title case. Then I want to join all those words back together. And I'm going to join them back with spaces. So I use a string with just a single space in it and call the join method on that. And what that does is it says, it takes an iterable like a list. In this case, it's going to be list title. It takes all the strings that are in list title, and between each one, it puts the string that called the join statement. So we're going to call it with a space, and we're going to join up list title, and we're going to return that value. All right. So let's see what we get when we call that. What's the title of BOB'(S) diner? Okay, and that worked. Bob's Diner. So let's have a look at the solution. The solution's used a few different things. So we've split the sentence, that's correct. And we put it in a list. This one we've called words. I called it list original. And then it's created the new list title. This one's called capitalized words. And it's created this list using list comprehension. And the way it's done that is, so this is a little bit advanced for the beginner people, but for people who are not beginners, then you should be able to understand list comprehension. Because this is such a familiar structure, where you have a loop, a for loop, you do a calculation of the new element to add to the list, and then you append it, then they've got this list comprehension which does exactly that. So there's the calculation of the new thing that's got to be appended into the list. We've got square brackets around the outside to say it's got to go into a list. And then there's the loop for W in words. And so in one line, we can do what's taken us these 4 lines here. Those 4 lines have all gone into one line, and then return a space to join all those capitalized words. And if you want to understand how join works, try putting something else in there, like equals, and see what you get. And you see you get Bob's equals diner. So it's joined the 2 words together with an equal sign at and just the end of the road. So you can see it's capitalized all those words, and it's put equal signs between each one. So we'll just change that back to a space. All right. Functions can have default values for their arguments. So here we've got a function with a single value argument. If no default value exists in a function def, then the argument must be supplied. So if we look at the help on string.split, we can see that it's got 2 parameters or 2 arguments, and both of them have got default values. So separator, the default value is none, and max split, the default value is -1. So because both of the arguments have got default values, we can run split without providing any arguments. But the way you define a default argument is in your function definition, is you write the argument name and then you say equals and then what the default value will be for that argument. So let's have a go at rewriting our function with a default argument. So we want to rewrite solution 7 to have a named argument, and the named argument is going to be called SEP, and it's going to have a default value none, and SEP is going to get passed through to split. So we'll take this shortened version of solution 7. So we've got the first argument is not going to have a default, so they have to provide a sentence in there that's going to be split, but then we're going to provide a second argument. It's going to be called SEP, and it's going to have a default value, and the default value is going to be none. All right, so when we split this, we're going to call split using a named argument. And when you call a function, you can also name, or you saw before, you can use a named argument, or we could have probably left that without the named argument. Sep equals none, and let's run that. So as we expected, it runs exactly as before. But if we call title now with an sep equals, and so this is what's going to be used to split the string up. Let's split it on underscores, and we'll stick a couple of underscores in here and see what we get. So print title, split. So at the moment it's, oh yeah, it's doing the same as before, obviously, because I've set sep equals none, but we want sep equals sep. So the sep here is the name of the argument in split, and the sep here is the variable sep that is from this argument here, which will take in whatever value we get. And so we can see now that it's split all the words up based on where the underscores were and not where the space was. So the D is now lowercase. And when we print this, let's join them with a different, let's use equals to join the capitalized words so we can see where the joins are. Yeah, so BO is the first word, it's capitalized. B apostrophe S space D is the second word, so it's got a capital B at the beginning. IN is the third, and ER is the fourth, and you see it's put a capital letter at the beginning of each one. So we've expanded what it can do. Let's have a look at here. Okay, so it wasn't in the task description, but it wants to use sep to be to join the capitalized words at the end. So it's done everything the same as us, and so let's have a look when we do that, and we can see it's the only two word breaks are here and here, and it's put them back in at the end, and the only capitals are right at the beginning: B for Bob, I for in, and E for So Peter's asked, shouldn't the default sep be a space? No, it's not actually. The default sep is white space. So if we had, and white space can be lots of different characters. So for example, if I had Bob's diner, so if I had /t in there, /n, bit of white space, and none, and run that, then it's replaced the /t, which is a tab, it's replaced the /n, which is a new line, and it's replaced the space, which is white space, because they're all white space. So white space is the default, and sep equals none means white space. You're going to do sep equals space if you wanted to only do space characters, and sometimes you want to do that. You want to keep the tabs and the new lines in place and only split it up on the white spaces. So in that case, you would do sep equals space. So let's try space here. So you can see the tab is still in there, but it hasn't created a capital for this B. The new line is in there, but it hasn't created a capital for the D. Here is where we had the space, and now we've got an equal sign, and it's capital. Put a capital on the I. So if you looked at the help on split, using sep as a delimiter string, if max split is given, okay. If sep is not specified or is none, any white space string is a separator, and empty strings are removed from the results. Okay, I think that's the last of the tasks for tonight, but we'll have a look now how to unpack arguments. If you have all the arguments in an iterable sequence, like in a list or a tuple, you can unpack the arguments using the star notation. So, for example, here I put the list of arguments here. I put a tab character and a number 4 as my list of args. What am I doing? What function am I calling? Split. So I'm going to call split. So I want to split. I want to have, so remember, split had a maximum number of splits, so that's going to be 4, and I want to split on tab characters, not on spaces, not on new lines, just on tab characters. So I've got my tab separated value here. First one, tab, second, tab, third, tab, fourth, tab, fifth, tab, sixth. And I can run that. So to do this, I've got, I'll copy this. There's two ways I could have done this. I could do list args 0, comma list args 1. Because that's where my values are. They're currently in that list variable, and I want to provide 2 arguments to this split function. But what we've got is this, it's a keyboard shortcut. We just use a star in front of it and it unpacks it for us. It does the same thing. So you can see if I'd done it list args 0, comma list args 1, I would have got the same answer. First one, second, third, fourth, and then fifth and sixth. And you can see it's put in maximum number of splits was 4, which was the second number. It's split on the tab, not on space. So first one's got a space in it, and it's still left in there. So we've got 1 split, 2 splits, 3 splits, 4 splits. So that's what we expect. Now, when we did the same thing, when we did this with star list args, it gave us exactly the same result. So that's the star is like unpacking your arguments and then providing them to the function that you've put them in. So here we've got another one. We've got args equals my as a tuple with my and favorite in it. So this a tuple or a list. Tuple is just an immutable version of a list. So if I print args without unpacking and the separator, I get exactly the tuple that I put in. But if I say I want to unpack it first and then print it out and use the colon separator, you can see it's unpacked it into 2 arguments and put a colon in between them. All right, functions can be defined with unnamed arguments using that star notation to pack arguments. So I could define a function here, and I use the same notation. It obviously means slightly different. Here it means unpacking, here it means packing. So when you're calling the function, it means unpacking. When you're defining the function, it means pack. And so unnamed means, putting this in pack means I want as many arguments as you want to give me. I'm going to put them all into a list and work with that. So if I call unnamed 4, foo bar, then it's going to print that. So let's print that. And so you can see here it's put them into a tuple, and it's printed the tuple as a single item. Now if I tried putting names on those arguments, that will fail. And it's so like I couldn't even call it args if I tried args equals 4. Yeah, and let's delete that. That will fail as well. So if you really don't want someone to use named arguments, you can set up your parameters like that. All right, now there's another notation called the star notation, which is going to be used to unpack named arguments from a mapping, for example, a dictionary. So in this case, I could create a variable called kwargs, and it's got maximum split 3, sep as tab, and then I supply that to the split command, the split function, and I use ** on that, it will actually put 3 to the max split argument and \tab to the separator argument. So let's run that. And you can see now it's split up TSV with a maximum of 3 splits, and the fourth item has got 4th, 5th, 6th all with /t's in them, \t's. So similarly, that was unpacking. You can also use it to pack named arguments, non-positional named arguments, using the star notation to pack them. And so here's an example of packing. So this is more advanced stuff, so the beginners don't really worry about this. And so that's how you define them. So we've just created these names. The function didn't know what the named arguments were going to be. So this is really useful if you need to write a function where you want people to provide named arguments, but you don't know what the names are going to be before they provide them. So you put this ** keyword arguments here, and then you can find out what the names are by looking at the keys in that dictionary. All right, and I like to throw in something really advanced right at the end. In this case, this only works in Python 3.8 and later, so I can't even show it to you in this Google Colab notebook because Google Colab is currently using 3.6.9. But if you want to define your argument to your function to only use position arguments and not named arguments, you define it with a / after the arguments that you want to be position only without using names. If you want to define them to be keyword only, you can put a * at the beginning followed by all the arguments that need names. And if you want to have a combined example that's got position only right at the beginning, then standard arguments, and a standard argument can be named or can be positional, and then keyword only, then you define it using the / here and the * here. But like I say, I can't demonstrate that to you because if I have a look at what version of Python we're running, sys version sys. How much should be version? Yep. 3.6.9. So yeah, this won't work. All right, well that's all for tonight. I hope you've enjoyed it. Click like if you like the video, I guess. If you've got any more questions, I'll be still listening on the Slack channel. As soon as I stop the video, it will it'll stop the YouTube live chat, so I won't be able to answer any more questions on that. So next week will be Arun will be taking over. So keep tuned to the Slack channel to find out what the topics are going to be for that. And then I'll be, he'll do the next 2 weeks, and then I'll take the weeks after that. Hope you enjoyed it. That's all for now.